So the next one, in figure, a square OABC is inscribed in a quadrant OPBQ. So there is a square inside a quadrant. Quadrant means 1/4 of a circle, which is angle is 90 degree. Okay, so there is a square OABC inside the quadrant OPBQ. Again, it is given OA is 20 cm. That means side of the square is given as 20 cm. Find the area of the shaded region. Shaded region is very easy to identify. How we can find the area of the shaded region? Very easy, isn't it? How? Just subtract area of the square from area of the sector or area of the quadrant. Find area of the quadrant minus area of the square. To find area of the square, the formula is A square. Side is OA, isn't it? And OA is given as 20 cm. So it's okay. What about area of the sector or area of the quadrant? To find area of the quadrant, we need theta and the radius. Theta is clear because it is a quadrant. Angle is 90 degree. That is okay. What about the radius? Radius is either OP, otherwise OQ. Is it given? No. B is also a point on the circle, isn't it? B is also a point on the circle. So if I join OB, what is this OB? O is the center, B is a point on the circle. So OB will be the radius. Okay. So if I am considering this triangle OAB, it's a right triangle in which OA is 20, which is the side of a square. AB is also 20, which is the side of the square. Can't you find OB? OB will be the diagonal of the square. Same way, if I take the triangle, it will be the hypotenuse of the triangle. More than that, it will be the radius of the circle or radius of the quadrant. That is what we require. So what we are going to consider is, we are going to consider triangle, a right triangle OAB. And we are going to apply Pythagoras theorem. What is Pythagoras theorem? OB square, hypotenuse square is equal to base square plus altitude square. So OA square plus AB square. OA square, that is 20 square. Why? Because OA is the side of the square which is given as 20 plus AB is also another side of the square which is also 20. 20 square plus 20 square, that is 2 into 20 square, isn't it? X plus x gives you 2x. So 20 square plus 20 square gives you 2 into 20 square, that is OB square. We require only OB. We have to take the square root. Square root of 2 is root 2 and square root of 20 square is 20. So we are getting the radius as 20 root 2. Now we are able to find the area of the shaded region. So to find the area of the shaded region, area of shaded region is equal to area of quadrant. In the question it is given as quadrant, so we will be using the same notation, OPBQ minus area of square OABC. Okay, area of quadrant, what's the formula? Theta divided by 360 into pi r square minus area of square, what's the formula? A square. Theta, what is theta? 90 divided by 360 into pi, let it be 3.14 into radius. Radius we got as 20 root 2. Radius square, isn't it? That will be OB square. So we can write the value as 2 into 20 into 20. Actually radius is 20 root 2 and we require r square. That means square of this. Square of this means 20 into 20 and root 2 square is 2. Okay. Minus a square. What is the side of the square? It is given as 20. So 20 square. This is equal to, this get cancelled giving you 4. 4 and 20 get cancelled giving you 5. 3.14 into 5 into 2 gives you, here it is 10. Actually the value is 3.14 into 10. 5 into 2 is 10. And from here if I am taking 20 as 10 into 2, I am getting 10 into 10, 100. That 100 into 3.14 gives you the value 314 into 2. Minus 20 square is 400. Here also it is 400. What is 314 into 2? It is 628 minus 400. So while subtracting, we are getting the value 228 centimeter square. Therefore, area of the shaded region is 228 centimeter square.